Hey everyone! Ever wondered how your favorite apps like Instagram or games like Minecraft are made? It's not just a single step, it's a journey, and that journey has a name, the Software Development Life Cycle, or SDLC for short. It's basically a roadmap that helps us build awesome software in an organized way.
Our first step is all about planning. Think of it like planning a trip. We decide where we're going, why we're going there, and what we'll need, like money and a packed bag. In software, we figure out the project's main goal, estimate the cost, and check if we have the people and resources to get it done. Next up is a requirement analysis. Now that we know why we're building it, we need to figure out what it should do. We talk to potential users and ask them what features they want. For a food delivery app, for example, we'd list things like search for restaurants, add items to a cart, and make a payment. With our list of requirements, we move on to the design phase. This is where we create a blueprint for the software. We design how the app will look and feel, the buttons, colors, and layout. We also plan the technical side, deciding which programming languages and databases we'll use to make everything work smoothly. This is the part everyone thinks of when they hear software development, the actual coding. Our developers take the designs and requirements and start writing the code that makes the software a reality. They're the builders who bring the blueprint to life, creating all the features we planned earlier. Before we show the world our new creation, we have to test it. This is a super important step where we try to find any errors or bugs in the code. We check if all the features work correctly and make sure the software is stable and reliable for users. It's our final quality check. It's launch day. Deployment is the exciting step where we finally release the software to the public. We publish the app on app stores like the App Store or Google Play, or launch the website so people can start using it. All that hard work finally pays off. The journey doesn't end after launch. The last step is maintenance. We continue to support the software, fixing any new bugs that pop up and listening to user feedback to add new features. This keeps the software relevant and ensures users have the best possible. So there you have it. The software development life cycle is like a recipe that helps us turn an idea into a fully functional piece of software, from planning all the way to a happy user. It's an awesome way to bring digital ideas to life. Welcome. Today we'll dive into the software development life cycle, explore its phases, the 6 core models, and how to choose the best one. IEEE defines software engineering as the application of a systematic, disciplined, quantifiable approach to software's development, operation, and maintenance, what we call SDLC. Every SDS model incorporates these 7 phases, from initial planning all the way through ongoing maintenance. Why multiple models? No one model fits every project, so we choose based on factors like size, clarity, risk, and team makeup. The waterfall model is strictly sequential, moving through feasibility, requirements, design, development, testing, deployment, and maintenance in order. It's great when requirements won't change, but highly inflexible. The waterfall model follows a strict step-by-step flow. It starts with feasibility, then moves to requirements, design, development, testing, deployment, and finally maintenance. Each phase must be completed before moving to the next, making it ideal for projects with clearly defined requirements. When to use waterfall model? Use waterfall model when requirements are crystal clear, technology is well understood, and scope won't shift. Iterative waterfall model adds feedback loops after each test cycle, letting you refine requirements or design, but it requires extra planning. The iterative waterfall model follows the same structured steps, like requirements, design, implementation, and testing, but allows feedback loops. If an issue is found in testing, earlier stages like design can be revisited. This makes it more adaptable than the traditional waterfall. When to use iterative waterfall? Use iterative waterfall when requirements may change mid-project, but you still want a structured process. It's helpful for catching issues early through feedback loops without starting from scratch. The evolutionary model develops software in small increments. Each version adds new functionality, allowing users to give feedback between cycles. This flexibility makes it easier to adapt to change over time. It's also called the incremental model. Use the evolutionary model when you're working on a large, complex project where early delivery matters. It's ideal if requirements are expected to change and users want to see progress early. Just be mindful. Integrating all the pieces later can be challenging. The evolutionary approach means building software in parts and improving it over time. Two common types are the prototyping model and the spiral model. Both allow continuous user feedback, early delivery of working software, and flexibility in handling changing requirements. The prototyping model starts by gathering basic requirements, then quickly builds a working prototype. Users review it, give feedback, and improvements are made through multiple cycles. Once finalized, the actual system is developed. It's best when requirements aren't clear at the start. In the prototype model, a quick version of the system is first created. Users evaluate the prototype, and based on their feedback, the requirements and design are refined. Once the prototype is approved, the full system is developed. This model helps clarify needs early in the process. Use the prototyping model when requirements are unclear, user involvement is high, and the user interface plays a key role. It's also great when frequent feedback is available. But be cautious. It can lead to scope creep and may delay final delivery if not managed properly. Software engineering principles are guidelines and best practices that help us create software that's reliable, efficient, scalable, and easy to maintain. Here are golden rules that guide developers in designing and maintaining software effectively. Modularity means dividing the system into smaller independent parts for easier building and debugging. Abstraction hides extra details so we can focus on the main concept or functionality. Encapsulation bundles data with its methods and protects it from direct outside access. The DRI principle says avoid repeating code, reuse what's already written. KISS means keep design simple. The simpler, the fewer problems you'll have. Yejinai reminds us not to add features until they're truly needed. SOLID is a set of 5 rules for object-oriented design to keep code flexible and reusable. In test-driven development, we write test before coding, which helps reduce bugs. So by following these principles, we create software that's The spiral model is a risk-focused, iterative approach that combines waterfall structure with prototyping's flexibility. Each cycle, or spiral, refines the system through planning, risk analysis, development, and feedback, making it ideal for complex high-risk projects. Spiral involves four main phases that are: planning sets goals and limits, risk analysis tackles potential issues, engineering builds and tests the software, and evaluation reviews results to guide the next cycle. The process begins with defining the software concept, followed by a preliminary requirement analysis. Next comes designing the architecture and system core. A version is then developed, implemented, and refined into the final version. Customer feedback is incorporated to make improvements, and the updated version is delivered for use. Use the spiral model for large, high-risk projects with unclear requirements, frequent changes, and a need for high reliability or security. Agile SDLC model. The Agile model is an iterative approach to software development that divides the project into small cycles called sprints. Each sprint covers planning, designing, building, and testing, delivering a working piece of software at the end. Agile steps start with gathering requirements and designing solutions, followed by developing and testing features. After deployment, user feedback is collected and used to refine the product in the next sprint, ensuring continuous improvement. The Agile model is a continuous cycle that starts with gathering requirements, followed by design, development, and testing. The completed features are reviewed, deployed to users, and refined based on feedback, repeating the process for each iteration. Characteristics of the Agile model. The Agile model is iterative and incremental, highly flexible and adaptive, encourages strong customer involvement, delivers results fast and continuously, and thrives on close team collaboration.
Software myths. Software myths are common false beliefs or misconceptions about software development that can lead to unrealistic expectations and project problem. Types of software myths. 1. Management myths. 2. Customer myths. 3. Developer myths. First, management myths.
Myth 1. Managers must know everything. Reality: they guide and coordinate. Team members provide solutions. Myth 2. More people equals faster results. Reality: adding people late often delays the project. Myth 3. Management means only planning and controlling. Reality: managers also motivate, inspire, and solve problems.
Second, customer myths. Myth 1. Customers know exactly what they want from the beginning. Reality: needs change over time, requirements evolve. Myth 2. Changing software after release is easy. Reality: changes take time, effort, and can create new bugs. Myth 3. Just saying I need a system is enough to start coding. Reality: we need detailed requirements to succeed. Third, developer myths. Myth 1. Software development is a straight line, step by step. Reality: it's iterative, often needs rework and experiments. Myth 2. Coding is the only job of a developer. Reality: developers also test, debug, document, and communicate. Myth 3. Testing is only after software is ready. Reality: testing happens throughout development.